Welcome to this comprehensive tutorial on building a supply chain solution using Hyperledger Fabric. In today's world, supply chains are complex and often opaque. They require robust systems to ensure transparency, traceability, and efficiency. Hyperledger Fabric is a leading blockchain framework that provides the appropriate capabilities for constructing a detailed supply chain solution. By the end of this tutorial, you'll have a solid understanding of how to implement a supply chain solution from scratch. To begin with, let's make sure that you have the necessary tools installed. You'll need Node.js, npm, Docker, and Docker Compose. I'll also be showing you how to set up a Hyperledger Fabric development environment using the Fabric samples provided by the Hyperledger team. Let's start by downloading the Hyperledger Fabric samples. Open your terminal and run the following commands. Now, we need to install the required binaries and Docker images. We can do this by running the Bootstrap script provided in the samples directory. Once the setup is complete, we're going to create a new directory for our supply chain project. Next, we need to define our supply chain network. In Hyperledger Fabric, a network consists of peers, orderers, and organizations. We will create a simple network with two organizations, supplier and distributor. Now, let's define the configuration files for our network. Start by creating a file named dockercompose.yaml. This file will define our peers and the network structure. The above YAML file specifies two peers for the supplier and distributor organizations. Each peer has its own address and logging level. Next, we need to set up our chain code. Chain code is the smart contract that will handle business logic in our supply chain solution. For this tutorial, we will write chain code in Java because it allows for robust applications. Begin by creating a folder for your chain code. Create a Java file named supplychain.java. This file will contain all the necessary logic for our supply chain operations. In this Java class, we define a contract for our supply chain. The createItem method will be responsible for adding items to our supply chain, while the readItem method will return information about a specific item. Now that we have our chain code set up, let's package it so that it can be deployed on the Fabric network. We'll create a build.gradle file in the chain code folder to define how to build the project. Next, we will build our chain code by running the following command. Ensure you have Gradle installed on your machine. After building our chain code, we need to deploy it on our Hyperledger Fabric network. To do this, we will create a script to deploy the chain code using the Fabric peer CLI. Now that our chain code is deployed, it's time to set up the client application that will interact with our blockchain network. We can use Node.js to build this client application. Create a new directory for the client application and navigate into it. Initialize a new Node.js project using npm. Install the required dependencies for interacting with the Hyperledger Fabric SDK. Now, create an index.js file where we will write the client application logic. In this code, we have set up a client application that connects to our Hyperledger Fabric network and submits a transaction to create a new supply chain item. To run your application, execute the following command in your terminal. If everything is set up correctly, you should see a message confirming that the transaction has been submitted. This means our item has been created in our supply chain. Next, let's add functionality to retrieve item information from the blockchain. We'll extend our client application to read the item created in the previous step. By adding this code, we can evaluate a transaction to read an item from the blockchain. This interaction demonstrates how our supply chain solution provides visibility over items in transit. So far, we have created a basic supply chain application. However, real-world supply chains require additional features such as tracking item history, managing multiple items, and implementing consensus measures. Let's implement item history tracking. We can modify our chain code to maintain a history of status updates for each item. Along with this new method, ensure you store previous statuses in a list or database object to track changes over time. For testing, we should create more transactions. Adjust your Node.js application to update item statuses as necessary. Now that we have added item status updates, we can also implement a method to retrieve the complete history of an item. This is important for ensuring traceability in the supply chain. We can then expose this method through our Java application and invoke it using the client side where we make API calls. Next, let's discuss how you can secure your supply chain application by implementing access control. Hyperledger Fabric provides an authorization mechanism using chain code level access controls. You can define policies that restrict who can submit certain transactions. For instance, we only want suppliers to be able to create new items. With the above implementation, you will ensure only appropriately enrolled identities in the Fabric membership service provider can invoke certain transactions. As we build upon these features, you will find that testing is crucial. Ensure thorough testing on your chain code and client interactions. Hyperledger offers tools for unit testing chain code in Go or Java. Next, for better user interaction on the client side, you might want to implement a front-end UI, perhaps using React or Angular. This way, users can easily track items across the supply chain visually. In support of this, consider creating RESTful APIs on your Node.js app to provide a better interface for your front-end to consume. In this way, we start building a complete application that provides transparency and efficiency in the supply chain. Now, let's talk about deploying your chain code to a production environment. You will want to ensure you're following best practices like versioning your chain code, utilizing more robust data storage, and perhaps integrating with existing systems. To deploy in a production environment, you might also want to implement monitoring tools to observe the health of your blockchain network and chain code performance. When you are ready for deployment, consider using Kubernetes for container orchestration to manage your network efficiently. In summary, managing a supply chain using Hyperledger Fabric allows for greater visibility and security. We have covered the setup of a blockchain network, deployed chain code, built a client application, and discussed best practices for access control and deployment. Now, it's your turn to experiment. Take what you have learned and start building your unique supply chain solution. There are numerous possibilities to enhance functionality and user experience. Thank you for joining this tutorial on building a supply chain solution with Hyperledger Fabric. If you found this content valuable, please like, subscribe, and share. Don't forget to check out all the resources provided in the description below.